All right, so hi everyone. Welcome to the fourth webinar in our series, the IEA Wind Task 43 Metadata Challenge webinar series. Today, we're really happy to have Gavin Chait from, I forgot to ask you how to pronounce the company's name. I asked you how to pronounce your name. Whythawk. Okay, yeah, Whythawk. Okay, great. And he's going to be talking about publishing research data review and reuse through schema-to-schema data transformations. Just a quick introduction this is the schedule that we always have. So I'll do my brief introduction and then I'll pass over to Gavin. He'll present. The idea, Gavin, is to do it roughly until past, but it doesn't matter if it's 5 minutes longer. But we just want to have time for a Q&A session at the end, and then some sort of summary and closing. Maybe there'll be some conclusion about something we should do together or something. So just the introduction to this series that we basically always do. So I just want to quickly tell you what the IEA Wind Task 43 Metadata Challenge is. IEA Wind Task 43 is part of the IEA Wind Technology Collaboration Programme. And in this programme, there's many different tasks on different topics where the international community has got together and said, this topic's important for us to work together on. And Task 43 is called Wind Energy Digitalisation. The website's given here. I'll put the link in the chat afterwards. And the Metadata Challenge is part of one of the work packages about data standards and sharing. And the goal of this challenge is to research into metadata and knowledge engineering for wind energy applications, and then use the results to develop recommendations for the sector. So we're doing various things. We're working out how to manage metadata and schema. We're working out how to define schema for data and metadata. We're doing a review of existing initiatives and works. So actually, we're currently writing a review paper on that. And then the fourth part is sort of more like the communication and the politics part. And as part of that, we started this series in December. And the main goal is to just talk more about the topic of knowledge engineering and metadata and fair data in general, and try to connect wind energy experts with knowledge engineering and fair data experts. And so why is the topic of knowledge engineering important? Well, the successful digitalization of the wind energy sector is one of the key drivers for reducing the costs and risks of wind energy. There are many opportunities associated with that, including digital twins, predictive maintenance, drones, AI systems, and these can all contribute to reducing the costs and increasing the amount of energy. But the thing is that for such solutions, we don't just need the physics and the simulations, the data analytics, the understanding of how the wind turbine's behaving, but we also need AI systems to process, interpret, and perform logical operations on structured data if we want to automate anything that we're doing or make any automated decisions. And this is what we refer to as knowledge engineering. In order to do that, we actually need the structured data in the first place that represent the information that can be used by these systems. And this is what we call knowledge representation. So why do we want to, or what are we doing towards understanding knowledge engineering better? Well, first of all, we're trying to work out what all these different terms mean, and we've started a glossary as part of IEA Task 43, which is in development. I think we're going to add the terms semantic artifacts to that list after a conversation yesterday. So we're still learning, and we're trying to work out as well as what all these terms mean, like what do we actually need to know, what's been done so far, how can we learn from knowledge engineering experts, how can we learn from people who've got experience in other domains, how can they maybe learn from us, because I think wind energy is a quite difficult use case. It's a very interdisciplinary topic and quite complex, but then also how can we work together? Hopefully we can contribute to these questions today. Gavin's going to talk about data sharing, and what I just want to go into here is why do we need these type of tools? So the first thing is that data sharing is kind of important, and it's a growing topic if we want to implement digitalization, and it encourages more collaboration between people in general, which can result in important new findings and innovations. it's efficient because it means that people don't have to reinvent the wheel every time they're doing something, and researchers and modelers can share resources. It also then leads to more robust data and analytics. Obviously, if you test your analytics on lots of different data sets, it's more likely to be more robust. It also helps companies generate ideas or learn new ways to process data. And it just brings more intellectual power and people from different disciplines and different perspectives together. But as we all know, it also generates fear and resistance. It creates legal issues that need to be solved. Sometimes those two go together, and people pretend that they have legal issues, even though they're just actually afraid, and they delay any efforts to share data. It opens up vulnerabilities and it challenges the norm. And so this is why we need easy to use accessible solutions like what I think Gavin's going to present today. So with that, I would just hand over and ask you, Gavin, to share your screen, introduce yourself, and yeah, have fun, everybody. If you've got any questions, just speak or put your hand up in the chat or write in the chat, and we'll keep an eye on that. All right.
Cool. Okay, so I'm a data scientist specializing in ethics and curation, and a lot of the work I've done over the last few years has been in economic development and basically looking at econometric data. So what I'm about to show you in the UK causes terrorism. Since we're talking about pushback and resistance to publication. So firstly, Cthulhu loves data. Okay, this is a picture of Cthulhu at the recent RDA plenary. And where there are people and where there are data, Cthulhu loves to offer advice. And the sort of data that Cthulhu loves looks like this. This demonstrates all the worst aspects of some of the data that researchers end up either sharing and producing or needing to somehow figure out how to use. These are from a series of spreadsheets. There were about 100 of them, tables. This is from the original Millennium Development Goals, the Human Development Report, before the World Bank caught open data religion. So for 2 years, you had to buy these spreadsheets. If you wanted to track and compare different countries, you needed to reconstitute these spreadsheets. And a lot of us did it at the time, and it involved literally hundreds of hours of reconstitution, okay? No doubt whoever produced these thought they were pretty. They're horrendous. They're impossible to reuse, okay? So going into COVID, my longest project, my longitudinal study is a commercial property database of every single UK commercial property. I track and update on a quarterly basis all commercial property tenants, the rates paid, the amounts, the vacancy dates, everything that's happening, okay? And going into COVID, after several decades of disinvestment and gradually falling revenues, local authorities were taking big risks. They were buying up their city centers, they were spending a huge amount of money, they were demolishing them, and they were building a whole bunch of new shopping centers. This, from a research perspective, raises a whole bunch of questions. Why are they doing it? What are the outcomes? What are the long-term impacts? From a pure energy perspective, is this more efficient? My view is that businesses are actually becoming more efficient, which should lead to greater vacancies. You need less space in a world of the internet because you don't need such big shops. But from a government perspective, that's a nightmare. So the UK government's response was levelling up, £4 billion, which would go to local authorities based on proven need. The question is, how do you define proven need? Well, you need data. And the UK government used mine and then wrote a formula on top of it and allocated the data accordingly, which resulted in outrage. Lots and lots of local authorities screaming, bias, and we ended up being sued, or at least the government did. And the question they had to me, spent over many, many hours, was, can you prove that the source data that we used has a real context, that it came from somewhere, that you didn't mess with it, that you didn't destroy that source data? Now, I should mention, the data that we get is Cthulhu data. There is no schema. There is no standardized way of presenting the data that we get. We get it in however it arrives. You know, hundreds of different formats of spreadsheets, archaic data structures, weird definitions that bear no relationship to the actual mandatory things that they're supposed to be doing. We need to reconstitute that, okay? And the way we've done that is through a really sophisticated piece of software. So OpenLocal is the database. It's a history in 35 million rows. And what we do is we reconstitute their data. We realign it, we bring it into one place, and we make sure that it's accessible. And that we make available to universities all over to do all sorts of research. And that research can be really broad. Do tax rates changes cause business closure? Where are businesses really in combination with where people think they are? So where is a main street or a high street in comparison to where the planning council thinks that the boundaries should be? Who wins and loses from COVID commute changes? And then energy consumption. How do you measure energy consumption in a world of operational businesses? If you look at it purely from floor area and divide by energy, you get a very different idea of energy use than if you deflate by the type of business and the actually operating ones. Okay, so there's a lot of different research use cases here. We produce these sort of research tables, which are designed to do precisely what is happening here. Just basically do a screen grab and paste it into a PowerPoint, and off you go. All of the stuff is there, and you can talk for hours. But what you'll notice in the top right over here is a little publisher quality index. So this is our transparency through the research process. So wherever we present data, we also present a means to unpack where that data come from and how to conceptualize our source data quality. Okay, so that looks like this. So that report is for Kensington and Chelsea, and this is the update history, 2017 through, and this is a multiple page table, but all the way through to 2023. We're busy with, in a few days, we will finish the latest quarter. And you can see here how we got it, the number of properties there's supposed to be, the number of occupiers we actually got, the matching quality, whether we got names, whether we got dates, whether we got voids, whether we got reliefs, and then a reference to the actual link. Now, in the open data world, there is awful link rot. So the references that we produce to actual links frequently go nowhere because the local authorities that we get our data from have no regard for data curation. So they might update the page with the same link and put something else on it. They might remove the page entirely. And so what we also do is maintain the original data. So this is the project that I've been running for the last 7 years. And particularly as these data age, 2016 doesn't sound very long from a longitudinal study perspective, but in our case, for most local authorities, maintaining more than a year's worth of data is highly unlikely. So we are, in many cases, the single point of truth for everything that is happening in this research sector. And just about every single university has some form of spatial economics research team. Anywhere you go in the world, the data that are used may be very local. Most universities usually pick the neighborhood outside the front door of the college, And so their students become extremely well versed in the local neighborhood of shops and restaurants. But the techniques used, the data collected are pretty much the same everywhere. So when these data are lost, we lose a whole bunch of stuff. We lose the ability to prove that it's true because the original source data are not really online anymore. But we also lose some of what we had to do to make the data interoperable, the schema-to-schema transforms. So what we do and have done is just maintain all of it directly. So when I talk about data probity, and for me, this is kind of the root of what we need to do as researchers, because you can have great systems, you can be collecting great telemetry, you can be collecting anything. The challenge is getting back to root, getting back to that source, and proving that what you did, the underlying assumptions. So even if you're collecting, say, sensor-based telemetry, where you put the sensor is a human decision. Okay, if it's pointing slightly in the wrong direction, if it's miscalibrated in some small way, it's really hard to know that 5 years down the line from a table of data, because all you've got at that point is just the numbers. Okay, so when we talk about probity, we're talking about an identifiable source, very specifically how the data were collected. What was the process by which you decided to collect these data from this point at this time? To document that as much as possible. Then what I do and think is critical is transformation before analysis. There is a lot of software out there that will help you basically find patterns in data. There's any number of systems that you get now, and we talk about some of these AI systems, which essentially are just looking for regressions and patterns, are going to mine your data and come back to you and say, hey, look, I found a pattern. You're not doing research anymore. You're looking for shapes in clouds. So you need to start with a research question. You need to know what you're asking of your data before you have a look at it. Otherwise, you are not asking questions. You are being led by the data. Your data should guide you, not your question should guide you, not your data. Okay, your data is supposed to answer the question. So after that, transparent methods. Everything that you do to change that data should be saved in some way. One of the challenges with a lot of the data transformation that people do, the crosswalks, the data wrangling, whatever you want to call it, is that it results in destructive change. That there is no way to know how you got from source to the data you used in analysis. Something happened, something was done, but there's no documentation. And it can be a very manual process, meaning that to test whether it replicates, you'd have to manually perform those steps yourself. So we need algorithmic ways of doing that. I like to ensure that we have point data before aggregation. I don't like to work with other people's aggregations because, again, you lose that transparency. You don't know how they did the aggregations because you don't have access to the original point data. Somebody tells you that there's an average unemployment rate or an average vacancy rate or an average something. Average of what? Within what boundaries? What outliers were left out? That sort of thing. So the whole thing, repeatable, auditable, trail. And this is the system that I built into what we do. And the way we do it, the first thing is what I'm calling a minimal transformable schema, which is that every single data set, no matter how brutally ugly, can be reduced to a defined schema. Okay, that means that Cthulhu spreadsheet, as hideous as this looks, if you work symbolically, you are uninterested in the form of this. Okay, don't look at the data. It still has columns, even if they don't line up. Even if the header rows over multiple rows, they still exist. So just throw in a header row and design your script for transformation from there. Okay, so that's kind of how we work. Do not worry, do not get confused, do not allow this type of data to baffle you, because it becomes unusable and you start doing things that are destructive. And so this is now the project that I'm working on. So we've had a data transformation system in our software for the last 7 years, and it works really, really well, but it is designed just for our purposes. It's got a single schema that we use to transform all our wild data into, all our ugly data. And we've got a nice drag and drop interface, and it produces all the scripts, but it is not generic. It doesn't work for anybody else. So as I am funded by the EOSC Future program to basically develop what I'm calling Wicked, which is a suite of tools which will be open source and will include a drag and drop system that will allow you to basically, without being a coder, create transform data with an auditable record ready for publication. Okay, the whole point here is you may not be able to publish your source, or it may only be accessible via an accredited portal or a microdata portal or something like that. But the transformations, the schema and mechanisms should all be released. So in our case, this is exactly how we work with that sort of Cthulhu data, okay? So you import Wicked, you write these 4 lines of code, you now have a schema, okay? The set field categories here, you define a category. I got a question today, somebody emailed me, was we work with data, we've given names to things, but it's an open text field, and so people spell it in different ways, and now it's getting confusing. Cool, turn it into a category. Just hit a button, find all the uniques, and now your transformation schema is define the category terms you want to use. Now, country names are, you might think, oh, country names, easy. But, DRC is DRC, the DR Congo, Democratic Republic of Congo, Democratic Republic Congo, Congo, Democratic Republic of. There's no one name. So you need to categorize it, and then you can use that. You can basically say, these names, whatever they are, actually are these. This is the exemplar term. And that can then be documented. So on the right is the destination schema. That's what we want it to be. We want to have a nice, clean schema that looks like that. And in the program, there's a little thing called an action script. Action, which is what you want to do, which is basically based on the R API, destination column or field, and then what you want to do to it. Which columns are you drawing from? And then, depending on how you do it. And it can be recursive, so you can actually embed other actions inside the action you're doing. And then this is the full script, which you don't need to worry about. But essentially, this short script, which is technically readable, transforms that data into that. Okay. And that is usable. Okay. So at that point, you now can use that. And what's great is you can run that processing on the 100 different terrible human development report spreadsheets. And now you can finally merge them and start actually doing analysis. So this is the drag and drop that we currently use. This is what our system looks like. So we import a data set. We get a little view of what it looks like underneath. These little X's and Y's here tell you this actually came from multiple spreadsheets. So this was merged together. And then you drag and drop. And these little red things here are the action scripts that can be done. So you can create a new column. You can order them. Order by newest essentially allows you to select by the latest date of a particular term. There's calculations you can do categorizations, and you can do joins. You can merge columns together. So that's how we work. And this is going to become a new, completely generic system that anyone can use. So just ending off the presentation here, these are the protocols that we stick to, this is what I recommend when trying to publish and work with research data. Mostly it's to maintain the source as it came from source on collection. Okay, no messing with the original data, no matter what it looks like. We reduce all our data, all that source data, to a minimum transformable schema, an MTS. Okay, we then pick sensible constraints. Those constraints are what kind of are your acceptance criteria for your data. If your data are outside your acceptance criteria, you have a problem. It could be that it's beyond the telemetry sensor allowance. You know, you're going at 200,000 kilometers per hour for a wind turbine blade, and that possibly breaks some of the laws of physics, so therefore there's a problem. You make no destructive changes so that we can be reviewed. We were sued through, for this leveling up project, and I was able to basically show exactly that the source data were theirs, that the local authority was complaining about data that we got from them, and they may not like it, but that's their problem. So we were clear, and the problems all went away. I don't think anyone was happy, but again, that's not my problem. And we document everything. We kind of regard what we do as we expect to be audited. We expect not to be trusted. That our role as curators is to provide a good data set for analysis, and we expect that we need to prove at every step of the way that what we say is a reflection of the source. If the source itself is wrong, then the process should reveal that, but we shouldn't conflict during the process. And finally, we should cite everything. So everything that we produce comes with a citation built into the schema. So the schema, the transformation methods, these are all separate files. They're JSON schema files, and in them is a field for citation, and we use BibTeX citation methodology. So every single thing has the name, the version, who did it, and why. And that's us. So Wicked, this little website is currently live. It will hopefully turn into a full operational system by the end of June, at which point you'll be able to deploy your own systems. It's going to be based on Docker, so you can simply download it, throw in your own keys, hit a button, and build and have a fully running system on whatever infrastructure you have within a few hours. There's also a Python library that you can just build into your own software. And we'll go from there. We'll also allow people to use the system itself to do their transformations online. But if your data are in the millions of rows, then I'd probably prefer you do it on your own infrastructure, because then you start sort of creaking at the seams in terms of the hardware we need to provide. So yeah, questions. Open for questions at this stage.
All right, thanks very much. Questions, anybody? Don't be shy.
Yeah. I mean, on citations, my thing is that the process of managing data, the curation process within data science, is probably the most important part. It's also the most unrecognized. Some of the most complex technical work that needs to be done is before any analysis is done at all. Analysis on clean data is a breeze. Analysis on unreliable, messy data is an absolute nightmare. So the more we can bring transparency to the process, the more we can bring consistency to the process, the better for analysis. You don't have any gotchas. And I want to make sure that the software allows you, the schema, everything in it, allows you to cite the person who did all that work. Because right now data scientists aren't always, first tier members of research team. My ambition is that we become so.
Christian, you're turning your camera on. I'm sure that means you want to ask a question.
First, I can just kind of well, thanks a lot for an interesting talk, and I can only agree and reaffirm you that we've got the same kind of challenges in the wind energy industry, and we see those kinds of spreadsheets very frequently. And I think kind of as we're moving to using more fit for purpose way of managing data, we'll always have to deal with loads of legacy data that comes in those forms, and obviously also for all kinds of analysis, I can only agree that the transformation of the data is very often the biggest part of the work.
Yeah, one of the things that can sometimes be a blocker when you start as well is agreeing the schema. A lot of the debates that happen across the board are where two groups of people are like, yeah, but our data are really important and we need these fields and it has to be called these things because otherwise, nightmares happen. And each person, each research group can be wed to their particular schema. And they're not wrong. I mean, there are always good reasons why particular schemas are chosen. They're not random. And even if they were chosen randomly at the beginning, after you've run your database with those schemas for 10 years, well, now the ground has a shape, and it's difficult to do anything about it. So the idea behind this workflow is the transformations. If the transformations are really easy, really quick to run, and they're very transparent, then you don't need a long process of agreement on what the schema should be. All you need is the crosswalk. All you need is the script that tells you how you marry one schema to another schema and the trade-offs that need to be made to do that. During the RDA plenary, one of the things discussed was reversibility, that sometimes you can go from one schema to another schema, but it's not reversible. So if you're using, specifically if you're using categorical data, categories, sometimes you can go in, but you can't come back out because you lose data. The whole idea behind a lot of this is data protection, is patient anonymity, is, it depends. But I mean, if you're sampling at a rate of 1 a second and someone else is sampling at a rate of 10 a second, for them to migrate into your schema, they lose data. And you can't migrate into their schema because you don't have what happens in between. So there's all these different ways that there are trade-offs. But as long as that's transparent, it's all okay. It's where you fill in the gaps without being clear that those gaps were there in the first place that things become problematic. So yeah, that's what this is all really what I'm aiming for, is just this kind of, we need to do the work. And you don't want to sit around and wait for some sort of random agreement, which is beyond your control. And a lot of that legacy data would be great to do studies on, but if it takes 6 months just to organize it, that usually puts it out of research reach, because it's just who has the time.
Gary?
Yeah, just a little bit on implementation part so that I got it clearly. In your practical implementation, the destination schema is decided by the person who is running your software, right? Did I understand it correctly?
Well, I mean, essentially anyone can decide on the destination schema. So you could import a schema taken from somewhere else, or you could define your own destination schema. It depends on your needs. In our case, we have a destination schema, but we're actually going to restructure our entire project now because there's an emerging schema that the local authorities themselves have agreed upon. So we want to use that. But because we already have our own schema, well, now I need to write a new crosswalk. So we've got a crosswalk into the schema we're currently using, and then we'll have a crosswalk from there into the new schema. So essentially, it depends on the need. But at its most basic, the person doing the research can define their schema, their destination schema, and then transform everything into that schema so that they can do work.
Yeah, that was basically my question, is like how do researchers actually use it? So the idea is that we have all this metadata, and then I define my own schema, the destination, the one I'm interested in, and then I just drag and drop all this metadata.
Your research might be very lossy. You might be asking a very defined question, and you go from, I don't know, 30 or 40 different fields or from the source data, but you only need 5 of them. So you're trying to work with very big data. You're trying to do, big analysis, but you're working on a small computer. You don't want all the data, so you're happy to be lossy. There was another hand I think I saw.
Yeah, Anna Maria.
Yes. Thank you very much for your presentation. I like this because I think that it fits an idea that we had some time ago in a project. And as far as I understood, because I came late, I'm sorry, but it's about this distributed data distributed in different organizations. And each organization has a kind of a catalog of data with metadata and taxonomies. And then one searches the data. Then when they find the data, they would like to transfer the data in one format to the other. Is it right?
It can be. I mean, the worst case scenario that I work with is where there is no data curation at all. There is no agreed upon anything, and the data are just captured. And then we get it, and we have to figure it out from first principles with the context of knowing what the data are about. But we still have to kind of guess what they might have been intending when they collected it in the first place. And a lot of these data are very historical, so there's no one to ask. There's no one to phone and say, what were you thinking when you did this 2 years ago? But from a research field, even then, I mean, if you collect data from a study 5 years ago, and now a new researcher wants to reuse it, it might have been curated, the data might have been, there might have been metadata agreements, but it's a few years later, and you want to use it with some new data that you've just collected, you want to merge them, and you want to do some interesting comparisons. Now you're in a world where there may still be no one to ask. You may have some documentation that gives you some insight, but you may not actually have all the knowledge about why the data were collected and things like that. So this would allow you to do a little bit of experimentation without having to worry too much that there's an overhead of a commitment in time. I mean, to do complex data transformations or crosswalks takes a lot of time. There's coding, there's understanding the data, there's dealing with memory issues and everything else that might come with it. And sometimes that just stops research because you're going, well, before I even know whether I can ask the question I want to ask, I'm going to have to spend 2 weeks faffing. And if you can just spend a morning and fiddle around and get a rough idea, you might ask a lot more expressive questions. So that's sort of.
I think it was the idea that we had. I think I like it, but it's a kind of to find the data. You have to know that the organization has the data. In a way.
Yeah, I mean, there was a project I was involved with a few years ago where the UK was going to release a whole bunch of oceanography data, which was finally going to come out of various silos, and it was like terabytes of data. And it would be like the data sets that I was looking at was just thousands and thousands of random folders with mission 10, 1978. Okay. And in there, it's a whole bunch of references to water samples and temperatures collected by some boat that went out in 1978 and came back with some stuff. And, you know, cool, this is great. But now you've got thousands of these folders from thousands of different boats. They were all research projects in their own right, but it would be really great to align all those things and do some interesting stuff on climate change or saltwater acidification or whatever else might be going on. But it's difficult to know what's in the data because there's no schema until you open it. Some of the source files, you know, the actual software doesn't exist really anymore. So you're going to have to find some sort of thing that can open the file. You know, all those nightmares. But yeah, I mean, obviously to find the data in the first place, well, that's sort of, you know, the world of the open data thing where we go into these old databases and we say, is there any reason not to release this? A lot of the time, the reason is people don't like to release data because it doesn't have a schema, it doesn't have metadata, and no one knows what it is. And nobody wants to spend the time finding out. And it's easy to say no. So, yeah. I'm hoping it gets easier to say yes.
So what I'm wondering is how we can directly use this or expand this or do something, or do a small use case study for a wind energy application.
I mean, a lot of the area where I'm working at the moment has been like undergraduate dissertations or graduate dissertations where, you know, your students have a very defined period of time. And you might want them to do a very data-intensive project, but they're frequently limited by data accessibility. So they always end up doing the same projects on the same data sets because they're the easy ones within the time frame. If there are, you know, interesting data that are less accessible, then this approach can allow a much faster sort of early curation phase where those questions can be asked.
So, question to the wind energy people in the room: what is there a conclusion we can draw? Is there something we can do? Something we can test? How should we take this idea, this tool, which is actually going to be useful and usable? Is there something we can do with it?
I mean, the thing that comes into my mind right away is using data collected from various weather stations, various anemometers around to update your actually wind potential map, because obviously this data will be very messy. Everyone will be storing their weather data in their own way. It's just an idea.
Yeah.
Convince people to make catalogs, metadata catalogs, their data. And
I mean, for one thing, they could derive a schema, but I suppose you've got to look at the challenge here is what's their level of engagement? Is it something they want to do, or if you ask them for the data, they'd fling over some spreadsheets, and that's the extent of their involvement.
Yeah, that's what most people want to do.
Okay, so yeah, I mean, you might ask for a schema, they probably wouldn't bother. But if you could sort of pile all the data into separate folders and basically say this weather station here, you know, all of the data, and then somebody basically starts assembling it. I mean, you define a schema in terms of, and you can be pretty expressive because the system will allow you to put in defaults. So if, like, you know, because frequently with this is they might capture the same data in different ways, that's fine, but they might capture different data as well. So there might be fields that are just not available across all data sets. And in that case, you need to know what to do with missing data. So, you know, I'd suggest you need a schema that kind of gives you the most flexibility, and then just figure out who's going to sit there and open each file and do the dragging and dropping. But again, you could just set that as projects.
I would avoid collect data. I mean, I just would collect the information about data.
This is Anna Maria. I feel like this is a bit different topic outside of what Gavin Chait is saying. But going back to possible use cases, another one, it would be in case of structural health monitoring, is collecting data used for anomaly detection from different operators. But how much, because again, they would be storing it in a different way, in different messy ways. But the question is how much they would be willing to share it, even given the fact that you say, oh, we will completely like anonymize it, and like you will not be able to trace anything back to you, to like some specific operator or company. I don't know.
I mean, in this particular respect, is the risk to the person who captured the data that they would be embarrassed that they did the wrong thing, or what is the risk here? I mean, I don't know the field, so I don't know what the apprehension is around the data sharing.
I think Sarah is better poised to answer the question.
It's complicated.
I mean, it's a weather station, right? So who gets embarrassed if the data are wrong?
No, I was saying the data coming from the monitoring systems of the wind turbines to detect anomalies in their operation. So it's not really a weather station data. It's actually, yeah, their asset operations.
Okay.
I mean, nobody wants to share data because they're still in the old mindset of sharing means that I lose competitive advantage. And if they do share their data, they want, if they do get forced to share their data, they want to be compensated for it, for the effort that they would take to prepare it and apply a certain schema to it or structure it in a certain way. And we're
saying they don't have to. They just give you whatever they got, and we go from there.
Yeah, sure. I know. And this is also, I mean, so it's a project that I'm involved in, this We Do Wind project, where we're trying to, we're just trying to get people to share data and just say, give us the data and we'll do whatever with it. We've had some experience where we haven't structured the data. We've just provided the data how it was supplied, and it led to, unsurprisingly, to quite a few difficulties. But now we're trying a different approach, which is to say, okay, we will at least do some basic things to the data to make it structured, or at least to describe it in a reasonable way, or to make it fair to some extent. And but the trouble is that still, if we're going to do that, whoever we is, my university or a community of people, it takes time, right? And so there has to be some value created, or there has to be some compensation somewhere for this time, or somebody's got to pay for this time, right? So this is what we're currently trying to work out how to deal with, because I mean, if the people providing the data are just passing on that task to the people who are using the data, then the use of the data has to be so extremely valuable that it has to include that extra time required to structure the data. And obviously the quicker it is and the easier it is and the more tools we have to be able to do that, the better. But still, somebody's got to take that responsibility. And in our application in Wind, it's really not, like, nobody's taking that responsibility at the moment. I was in a discussion yesterday about with a load of wind energy companies who are talking about digitalization, and they're talking about this EU Data Act, which essentially seems to be trying to make people share data when they don't want to. And that instead of talking about, you know, which data could we share and how could that be useful, they're talking about how much compensation do we want to ask for when we're going to be forced to share this data. And it's very much the mindset as well.
I mean, the politics. From a curation tools perspective, this is designed to make it as fast as can be done, but it's not automated. I mean, I'm not a big fan of the idea of having some system derive your schema and do your crosswalk for you, because I think that's just going to lead to mess. But I mean, the reality is your analysis will take X amount of time. If developing the crosswalk, the schema transform takes a day, and then I don't know how big the data are. I can tell you that 8 gigabytes on my system with 32 gigs of RAM takes 2 days for a fairly complex transformation and validation. The transformation is pretty quick. It's the validation that takes a really, really long time. But it depends on what validation you're doing. So some of these things can physically take very little time to run, no matter how big the data are. And then you're into the world of analysis, and that takes as long as it takes to answer the question you're asking.
Sure. It's just this, but is this step of preparing, structuring the data, which obviously the analysis bit has got to be done by the experts, but the whole preparation thing, that's the, you know, the interface between the person giving and the person getting the data. That seems to be the thing where nobody wants to take responsibility, but it is clear to all of us that if you have accessible tools to reduce that time, then it's going to be a good thing. It's just not that quite clear for whom.
Question here about, you mean creating metadata catalogs or data catalogs? I mean, a data catalog then is essentially a search space or a data explorer that gives you access to physical data. That'll depend on the licenses with which you've been granted access to the data, whether you're even allowed to present it in some sort of searchable way. But a metadata catalog can at least give you, I mean, for me, the knowledge that Enqwyre raised about how do you know where the data are or that the data even exists, that's your metadata catalog. So maybe you don't have access to it again, but at least you know that it exists. So if you are able to, again, this program, the way it works is it's sort of the minimum transformable schema is basically open it, hit a button, generate the schema, add some descriptions to it, and a few minutes later you have a little JSON file that's got all the standard DCAT terms in a JSON schema file that allows you to publish a metadata schema. Okay. And at that point, you can put that in a catalog. And if you've got a catalog that can read it, then it's searchable, it's discoverable, and all those nice things. If you're allowed to put the data with it, then you've got a tool that actually then facilitates research and data interoperability and a whole bunch of other things. So I'd say the metadata catalogs are probably easier politically, because it doesn't imply access to the data, or it implies controlled access to the data. A data catalog is another story.
Yeah.
My idea was that the data catalog comes from a metadata catalog, because once I found different entries, I can see which entries are the best for me.
Yes. And I mean, part of the metadata is to tell you what the license is.
Yeah.
The metadata should tell you what the rules for access are, you know, whether you can reuse it. Johanna?
I'm sorry.
This is maybe
sorry, I don't mean to interrupt, but I have to leave.
Oh, okay.
Johanna, do you want to ask? Do you have a quick question?
Yeah, it's quick, but yeah, I'm working with wind production data, and one of my biggest problem is that the timestamps are different and not always complete, and it's different. How to say, it's either UTC or other time zones. I just wanted to ask.
Yeah, it's probably the longest, most complex piece of code is dealing with dates, and I refuse to deal with American dates. I'm going to have to add a whole American date section in. But yes, processing dates and normalizing dates and times is massively complex. But yes, it's one of the things that I do.
Okay, I'm really sorry. I've got another webinar starting now.
Okay, cool.
I have to leave you all, but feel free to contact each other. I think on the invitation, you can see each other's email addresses. Come to the next webinar. It's on the Enqwyre quite soon. You can't sign up for it yet, I don't think, but go to the website to find it. I just want to tell you that we've changed our website actually. So you might not, if you have trouble accessing it, I just want to put it in the chat quickly. That's the website where the next webinars are on. Okay, thank you very much for attending. Thanks, Gavin, for the great talk, and I hope we can talk further about how we can use your tool for a pilot project or a test or something. I think that would be really interesting. So yeah, see you all soon.
Okay, cool. Okay,
thank you.
Very much.
Thanks a lot.
Thank you. Bye.
Goodbye.